Should I start, sir?
Yes, sir.
Okay.
Proceed, sir.
Will introduce you.
Kindly check whether slide is changing or not. Is it changing?
Yes, sir, it is changing.
Sir, 1 minute, sir. Our faculty is going to start up, and then you can start with the presentation.
Okay, okay. I'm working.
You just mute, sir. You just go on mute, sir.
Good afternoon to everyone. I, Pavitra S, Assistant Professor, Department of Civil Engineering, VKIT, welcome you all to the second day of webinar on Design and Construction of Steel Structures. I welcome today's speaker, Mr. K Samanta, General Manager, Institute of Steel Development and Growth, to this webinar. I welcome you, sir. I also welcome Dr. C.S. Shashikumar, HOD, Department of Civil Engineering, VKIT, and faculties of Civil Engineering Department, and all the participants to this webinar. Yesterday, some broadcasting issue happened, so I'll introduce the chief guest once again. It's a pleasure to introduce Mr. K Samanta, who is working as General Manager in Institute of Steel Development and Growth at present. Prior to joining in INSDAG, he has worked in Tata Steel Limited for 10 years and 2 years in Jaiswal NECO Limited. He has experience of developing quality in fabrication of steel for more than 20 years. He has written few books and technical papers related to use of steel. It's a pleasure to have you here, sir. I kindly request you to take over the session. Samanta, sir, you can take over the session.
Okay, thank you. Good afternoon to all. Now, today my session will be on fabrication of steel structure. As yesterday, I have told you that steel quality and steel production scenario, availability of steel. Yesterday, wherever I have left, just I have started from that point only. Now, advantage of steel belongs to so many things, height, that strength to weight ratio, maintainability, low cost, low life cycle cost, etc. Now, as I have told in IS 800, that only one code has been mentioned as the steel production, specification, that is 2062. However, this IS 800 will be revised shortly, including all these codes. As I have told, 15911 is another code, which is having the specification from 165 yield strength to 215 yield strength. Then 2062 is giving us steel specification from 250 MPa yield strength to around 600. 11587 is giving us the specification of the weather resistant steel, that is the corrosion resistant steel, and 15103 is giving us the specification of fire resistant steel. As I have told you, that hardly any structure will be there which is subjected to both fire and corrosion. Normally, the structure in open atmosphere, it is subjected to corrosion, but when the steel is used in the building, it will be subjected to fire. Now, regarding fabrication, I would like to tell that steel is manufactured by the metallurgist, designed by the structural engineers, fabricated by structural engineer and mechanical engineers, erected by the again structural engineers and mechanical engineers. Metallurgists are nowhere in the picture who has exactly produced the steel. So steel is such a subject that it relates to many disciplines in our engineering. Interestingly, nowadays you will be finding more than 25 disciplines in our engineering education. However, nowhere you will be finding that fabrication engineering. That's why last 20 years I have tried to discuss with many experts whether there should be any discipline named that fabrication engineering, but somehow I remain unsuccessful. It has not started nowhere. So we have included in this subject in our training curriculum only, because this is a multidisciplinary subject. So many disciplines, metallurgist, civil engineering, mechanical, and other things are related to it. Even chemical engineering is also involved with this. So now this fabrication, exactly we are having standard 3 days training program. Now, as it is only 1 hour, just salient point I will discuss here briefly within this 1 hour. Now, so far availability is concerned, I have told angle, beam, channels, etc. are available in IS 802 808 specification. and your round section, that is the round circular section, is specified in IS 1161, and square section and rectangular sections are specified in 4923. Here I must leave another structural, that is rebar TMT bar, that is covered under IS 1786, which is used for the concrete structure. So as we will be concentrating only on the steel structure, rebar will not be our discussion subject. Now, so the specification of structural, I have told angle, beam, channel, plates, flat, circular hollow section, square hollow section, and to some extent cold form section covered under IS 801. Then approach to our quality. When I am talking about the quality in fabrication, what should be our approach? That as nowadays so many software are available, with the help of software we can do the precise fabrication with least time and least cost, but precision work and skilled work should be our objective. Then fabrication has two type of activity. One is in shop, another is site. Normally site fabrication is easy, but quality is compromised. Shop fabrication is very difficult, but it is more precise. Another cost aspect also will be there. If shop fabrication takes place, some government taxes are there, but if site fabrication, there is no such taxes. So many people prefer site fabrication, but when site fabrication will be carried out, then lot of local disturbance will be there, as well as the quality will be compromised. We should, if quality is our concern, it should be shop fabrication. Now, what are the activities being carried out in fabrication? As designer have given you the details drawing of the structure. According to the drawing and bill of materials, first we will procure the steel. Then after inspection the steel, if the steel is accepted to the contractor or the client, then first will be the cutting of steel, then joining will be steel. And after that, joining, when the frame will be ready or structure will be ready, then protective coatings will be there to prevent corrosion and fire. So these are the that mainly 4 activities. Now let us discuss that how to achieve the quality. As yesterday I have told, quality is our main motto. Otherwise we know somehow how to do the work, but quality if our objective, then we have to learn something, we have to follow some rules and standards. Now, so far procurement. After procurement, the steel has come to our workshop. So first is inspection. One is visual inspection. Now, when we will go for the visual inspection, all the steel sections having some dimensional tolerances. So I have to check first whether steel is as per the dimension or not. As I have told, dimensions are mentioned in IS 808 or 1161 or 4923. But the tolerances of steel sections are given in IS 1852 1985. Now another code here I am showing 12779, that is related to the wide flange beam. Now wide flange beam, initially it was included in IS 12778. Now in the recent revision, it has been included in IS 808. So the visual inspection, we have to check the dimensions. Once the dimension is acceptable. Now dimension, you see that if you follow 1852, then some tolerances have been mentioned here, that how much deviation in dimension is acceptable to us. The IS 1852 is the code, there all tolerances are given. If our actual measurement violate the tolerance level, then we have to reject the piece, because it will create some problem in our actual fabrication. Then again the same thing, it is giving the tolerances. Now some other tolerances are also there, which normally we ignore. It is my experience in the fabrication side, these things are not measured. That is the flange out of square or out of parallel. You can see from
Sir,
the
excuse me,
figure.
sir.
Yeah.
Sir, can you please mute the system volume?
Mute the system volume.
Yeah. Your laptop volume, can you mute it at the right hand side below?
A minute. Just a minute. But in that case, a minute. Just wait, I am doing that. Now, are you able to hear me?
Yes, sir. Yes, sir.
Hello?
Yes, sir. We can.
Hello?
Hello, sir.
Hello? Sir, are you able to
Sir,
hear me?
sir, we can hear you.
Hello? Hello? Hello?
Yes, sir, we can hear you.
So now if I system volume is okay, or I should make it totally mute?
It is okay, sir. It is okay. You can continue.
Okay. Now, sir, this from the picture it is clear that what type of tolerance is given. So if you go through the IS 1852, all the dimensional tolerance and the defective dimension has been given in that IS 1852. We have to adhere the code. So based on the IS 1852, we have to check the dimension of the sections we have got. So camber and sweep, all these things are given, and some percentage is also mentioned. Now the first, once it is, now the, if it is visually acceptable, then I have missed one slide here. That another thing is that strength level we have to check. Normally normally 250 grade of steel is available in the market. However, in case we have specified some 300 or 350 grade of steel, so we have to check the strength also. In that case, we have to get it tested with universal testing machine, so that the yield strength and tensile strength is checked. Once, if that's exactly, there are so many spurious material available in our market, so in case the steel is failed in the strength test, then we have to reject. Now I am coming to the first operation, that is cutting. Now cutting, as we are telling about, that these are the cutting procedures available: saw cutting, flame cutting, plasma cutting, water jet cutting, laser cutting. So these are the cutting procedure. Now, as this we will opt for the flame cutting, plasma cutting. Flame cutting is very common. Plasma cutting and water jet cutting, if we want to employ, then the standard of the cutting process will be very precision. Now you can see this is one portable saw. Up to 80 millimeter, 85 millimeter thick steel section we can cut, but it will make lot of noise as well as that sparking. So we have to be careful that exactly where is the workshop located. It creates a lot of noise, and not only that, it is time consuming thing. Now this flame cutting is very common. This is the process of cutting the steel section as the stream of cutting oxy acetylene. So with the help of acetylene, the gas cutting is carried out. Now it is very easy, and gases are available in any type of workshop. This is okay. But one difficult thing is that the tolerances here I have mentioned, exactly very difficult to maintain these tolerances. For example, if the thickness of the plate 2.5 inches, the tolerances will be in plus side only 0.125 inches, and no negative tolerances is allowed. But in gas cutting, very often we will be finding that tolerance we are not in a position to maintain. Not only that, when gas cutting is employed, exactly surface of the steel where oxidation is the possibility. So chemical composition and strength level of the steel also may go out of our control. So we have to be cautious in that respect. So though flame cutting is very easy and low costlier, however, quality is likely to be compromised. Not only that, this tolerance level also very difficult to maintain. So instead of that, plasma cutting nowadays very common in any advanced workshop. But plasma cutting is a lot of money, and even CNC plasma cutting is also available in the workshop, good workshop. Especially if the fabrication client is very quality conscious, we cannot go for oxy acetylene cutting. Rather, we have to go for plasma cutting. The basic principle is that the arc formed between the electrode and the workpiece is constricted to a fine board and copper nozzle, and increase This increases the temperature and velocity of the plasma emanating from the nozzle. The temperature of the plasma is in excess of about 20,000 degrees centigrade. Velocity can approach the speed of the sound. So obviously from here you can conclude that how much precise cutting is possible in plasma cutting. This is the schematic diagram of the plasma cutting, and left hand side is showing that what a typical low costlier plasma cutting machine is available. Normally that carbon dioxide or air plasma are used, but again if we use the inert gas like argon, helium, etc., then the quality of the plasma cutting will be more improved. So as we go for the quality concerns, if the cutting is necessary very precisely, we have to go for plasma cutting. Another technology has come nowadays, though I am not finding it many workshops, that is water jet cutting. In water jet crushing process, the cut materials using a jet pressurized water as high as 60,000 psi. This is then passed through a diamond or sapphire knowledge, which creates an extremely fine head water which will cut through the material. Some abrasive material are mixed with the water, and this water is injected on the cut piece so that the cutting will be very smooth. However, its strength level is less than the plasma cutting. So as a result, this water jet cutting, though technologically available, but it is not finding many applications or many clients. Rather, that plasma cutting is very common nowadays. Another is laser cutting. This laser cutting normally for structural application we are not using because it is too much costlier. Laser is very costlier, but with the help of laser we can cut the big steel pieces very easily, but it will be a costlier proposition. So we have to decide here that CNC plasma cutting is the best method of cutting, and big workshops should employ that technology. So with this, and for bolt hole, we have only two options. One is punch, another is drill. Left hand side it is showing that with drill we have to make the bolt hole. Another is punching with hydraulically we can punch the steel pieces so that the bolt hole can be formed. Now in drilling, the lot of tolerances will be there. So though it is cheaper, but it may not be very quality work. Rather, this hydraulic punching machine will give the more precise holes for the bolt. Now another is bending machine. We know hydraulic bending machine, and sometimes it is with CNC. It is available in the workshop. The machine is similar working methodology for both shearing option and bending option. The same machine can be used for both the operation. So CNC shearing machine also finding its place in the good workshop. Now I am coming to joining process. You will know that steel sections come to the workshop, and after that pieces have been made. Now according to the frame requirement, we have to join the two pieces. Now there are three types of joining process: riveting, bolting, and welding. Riveting is the oldest process, and it is very useful. If we go into any railway bridges, we will be finding it has been riveted about 100 years back. So rivet joining is very foolproof. It is proved to serve the life of the structure. However, it is very old method, and sometimes we feel that riveting is inhuman method. So as a result, nowadays riveting option is being phased out. Rather, we are trying to adopt bolting and welding. And welding is normally carried out in the workshop. Bolting is carried out at the site. However, inside sometimes welding is permitted, but that is not desirable. So riveting is on the way of phasing it out. So we should not discuss much about this. So let us go to the bolting option. Now, when bolting option, why bolt is? What is the advantage? Advantage is the time efficient joining technique, low cost, easy erection of structure, maintainability of the structure. Means when structure will be erected, if bolting hole has been made in the workshop, it is very easy to erect there. Only bolt, we have to put the bolt into the hole, and after that you tight and tighten it properly at the latter stage. And during maintenance also it is very easy. However, if welding is there, comparatively costlier, though it looks very nice, but it is comparatively costlier. And in case welding fails at the site, it may cause the accident. However, for bolt, if it somehow it indicates the failure, we can take the precautions well before the things. Then we are coming to bolting specification. Now here it is very interesting that if we go for the fabrication of big structure, suppose PWD, CPWD or any government authority, where inspection is being carried out at the site, then some specification has to be maintained or are maintained. But if we see any type of small fabrication where your inspection is ignored, there we will not be finding some neither the specification of the fasteners will be maintained. Fasteners means these bolts are called the fasteners, nor its quality will be checked. Now let me throw some light on the quality of the bolts. Specification of the fasteners and applicably should be understood by the fabricator. Now we are having our Indian standards. Indian standard IS 1363, it is defining the normal bolt of 3.6, 4.6 and 4.8 grade, and product grade is C. And another standard is there 1364. It is giving the bolt strength level 5.6, 8.8, 9.8, 10.9 with the grade A and B. Here grade A, B, C means the dimension are same, only the tolerances are controlled. Means when we are going to put the grade A bolt, it's costly. It will be costlier, but its tolerances is very precision. C grade is the most rough type of bolt. That's why its production is less. But normal that rural size or that where inspection is not there, they used to use this type of bolt just to reduce the cost. 3.6, 4.6, and 4.8. Now, high strength structural bolt is another concept. Nowadays, it is defined in IS 3757 and its applicability has been shown in IS 4000. Now, high strength structural bolt, only we are having two types of grade, 8.8, 10.9, though in American condition, another specification is there, that is, I think, 12.9. Now, what is the meaning of 8.8? What is the meaning of 10.9? Let us try to understand it. First figure, suppose for example, this is that 10.9. So out of 10.9, first figure, 10 is indicating the 100th of the nominal tensile strength in Newton per millimeter square. That is the your MPa. So that indicates in 10.9 grade, the tensile strength of the bolt is 10 into 100, that is 1000 MPa. Second figure indicate 10 times the ratio between the yield stress and the nominal tensile strength. So second figure, so for 10.9 scale, now 1000 is the MPa is the yield strength. So it's 90%, means 900 will be the yield strength of that bolt. And multiplication of these two figures will give the actual yield stress, that is the minimum. So that is, yeah, that is again the same thing, 10 into 9, that is 900 is the yield strength. So this is the meaning of the bolt grade. Now, unless this subject, this is very small thing to understand, but unless we understand it, we will employ the wrong bolt at the site. As a result, structure may fail. Now, principle of high strength friction grip bolt, what is that? That this is the figure you can see where exactly bolts is not, bolt strength is not the factor, rather friction between the two plates are the factor. The shank of the high strength bolt does not fully fill the hole, so shear and bearing are not the criteria for load transmission, as in the case of the rivet, which fill the hole completely. The nut is tightened to develop the clamping force on the plate, which is indicated as the tensile force in the bolt. This tension should be about 90% of the proof load. When a shear load is applied to the joint, no slip will occur. Now you try to understand this phenomena, that the plates are joined and bolts are tightened. However, bolt strength is not the criteria. Frictional strength, that is the resistance to slip, exactly that is the strength of the joint. So this friction grip bolt finds the application where fatigue is the criteria, vibration is the criteria, load reversal is the criteria, or dimensional stability of the structure is the criteria. In these four places, four conditions, high strength friction grip bolts are used. However, it is a costlier bolt, so fabrication cost will be comparatively higher. Then installation of HSU bolt in IS 4000, there are a number of guidelines there. There are four processes there they are telling. So these processes have been shown, where some bolt head can be rotated, or a nut can be rotated, or the DTI, the direct tension indicator, will be there. So many processes are there. Now let me describe one by one. One is direct tension indicator. When in the morning Mr. Basu was discussing that how the bolt should be tightened. Now bolt can be tightened. Bolt's tensile strength is the criteria. We have got that yield strength level. So around 70 to 75% strength should be applied in the bolt. Otherwise, bolt will go into the plastic stage beyond the yield strength. As a result, instead of tightening the bolt will become loosened once it starts yielding. So you see that one direct tension indicator figure is there. Here what you will get, that some projected portion is there, and in this projected portion, when you will be tightening the nut, this projected portion will shrink or will be pushed down, and it should push down in such a way that filler gauge, depending upon the size of the bolt, that filler gauge will be there. This after tightening, this projected portion will be pressed in such a way that the filler gauge will not pass into that gap between the nut and the direct tension indicator. So that is the methodology, and what will be the thickness of the filler gauge, that has been given here. So depending upon the size of the bolt. So this is one. Another, what we can do, that we can verify the bolt before application. So how pre-installation verification is taking place? 2 to 3 processes there. One is that Skidmore Wilhelm. This is one equipment where you give the bolt, and after that you tighten the bolt, and the tensile strength developing inside the bolt will be shown in the gauge. By that way, we can determine the correctability of the bolt. Then it is also another thing, hydraulic bolt load meter. Here it is also the same thing. You can see the bolt is there, nut is being tightened, and the tension whatever is being generated here, that will be shown in hydraulic meter. Then HFCG bolt tension the bolt, it is hydraulic bolt load meter application process, which already I have described. Now I am coming to again the same thing, that how much tension should be created. That comparison is there. That filler gauge, that DTI and hydraulic load meter, everything is given. Now tightening of the HFC bolt, we should refer that IS 4000. Already I have told you. There the all systems are given. Now depending on the size of the bolt, the details are given, that how much tension applicable forces we can apply. 8.8, 8.9, you see that it is given that in MTA the strength has been given. Now the difficult thing is that when we are giving the bolt tension, how to measure they are actually at the side. So though it is theoretical analysis, but very difficult to practice it at the side. Rather the torque is calculation of the torque and apply that is the best method. Okay, so I am giving you that portion. Now IS 800 is given for what size of bolt, what should be the tolerance in the hole. Now I am going to how to tighten the bolt to that side. Yeah, kindly check this one. The tightening torque, depending upon the bolt size, how much will be the tightening that grade is given 4.6, 6.8, 8.8 and 10.9, and what the torque will be there, it has been mentioned Newton meter. Now in where, as Mr. Basu was telling in the morning, in torque range we can set the torque, and accordingly we can tighten the bolt. Once the torque is reached, the tension has been achieved in the bolt, and then torque range will be free. It will not be possible to further tighten the bolt. So that torque range nowadays is very common in the fabrication side. Now torque range is also having many type of operating procedure. First is snug tightening, that is manually tightening. Then manual torque range, you set the torch and then try to manually tighten it. But if the tightening force is required very much, then we have to use that power tool. A number of power tools are there, pneumatically operated, hydraulic torque wrench is there, or heating rod is there. That is another technique. Tightening by mechanical elongation. That is that we have to tighten the nut, and after that some your strain gauge which will be fitted there. So we will check the elongation of the bolt so that we can decide how much stress has been created within the bolt. Now these are the standards, related standard. So for details, kindly go through all these standards. Now I am coming to welding. Now what is the welding? Welding, we are having three types of understanding by three types of engineering fraternity. One, what metallurgists understand by weldability. That metallurgists are telling parent metal will join the weld metal without formation of deleterious constituent or alloys. So this is the metallurgical definition. Metallurgists tell that after welding, the chemical composition or the microstructure of the steel should be as per the parent material. There should not be any deviation. But this metallurgist will not be in the picture when the actual fabrication will be carried out. They are mechanical and civil people will there. How mechanical engineers interpret that welding? The joint will be free from discontinuity, porosity, sinking, slack, or cracks, means any type of defects. Joints, after welding, joints should be free of any type of defects. That what are the defects of welding, we will go after few slides. Then how much is civil engineer concerned? They are telling whether there is some defect or not, what is the irrespective of their chemical composition or microstructure. Welds should be able to perform under varying condition in our service line. Means structure, once it is constructed, it will be subjected to corrosion, it will be subjected to fire, it will be subjected to wind, it will be subjected to accidental load, it will be subjected to earthquake. Welding, whatever process and whatever may be the degree of certainty in welding, but structure should sustain all the variety of the atmosphere for its service life, that is for still at least 100 years. So our three fraternity of engineers understand the weld in three ways. Whatever may be, irrespective of all these, weldability can be defined by the metallurgist, that carbon equivalent. As I have told in yesterday, then IS 2062 or in any other steel specification, you will be finding this number carbon equivalent. Carbon equivalent is less than 0.35, then welding is very easy. If it is more than 0.50, then welding will be difficult. Normally, manual welding will not be manual welding will not be adopted. Rather, automatic welding will be adopted, like submerged arc welding, etc., for the fabrication purpose. Now, fusion welding process. Normally, for structural application, we have all these seven types of welding are normally applicable. Exactly, total welding processes are there more than 100 types. Out of which, for structural application, only we have these 7 type of welding. Now, some color code is there. First is Oxy Acetyl Welding, that is the use of oxygen and acetylene gas, or that is gas welding, that we should not adopt because of its poor quality, as well as the some formation of the gases which are poisonous and injurious to health. So that's why Oxy Acetyl Welding, though it is prevailing still in our fabrication site, but we should avoid for better welding quality. Now, another is manual welding. There are two types. One is shielded metal arc welding and another is gas metal arc welding. These are the two types of welding. Normally, shielded metal arc welding or stick welding or manual metal arc welding are adopted at site. Metal inert gas nowadays, it is going into the site also, because of that some poor quality problem in the shielded metal arc welding, which I will discuss after this slide. Another automatic welding, there are 3 types. Tungsten inert gas, submerged arc welding, and flux core arc welding are applicable. Normally, these types of weldings are adopted in pre-engineered building where the welding is done in the workshop, not at the site, and these are fully automatic. Even manual, that gas metal arc welding also can be automated, But however, when this MIG will be automated, its name will be changed little bit. It will be fast core arc welding. Exactly, in MIG welding, we will use the bare electrode, but fast core arc welding, though similar technology, but inside the your rod or electrode, some flux will be there to prevent the oxidation. And plasma arc welding, it's a new invention nowadays coming into the picture, however not adopted because of its some limitation of the application as well as the cost involvement. Now, suitable of the welding process, here it is given, though it is not of much interest nowadays. Here it is only telling that FCAW or ESW, that is electro slag welding, is giving the faster welding method. But nowadays, as we are quality concerned, we prefer quality welding rather than faster welding method. So now welding position for manual welding, there are 6 welding position. One is flat, another is horizontal, another is vertical up, another is vertical down, incline and overhead. I am telling you, so far skill of the manual welders are there. They are very comfortable with the flat. Even if it is horizontal, it becomes difficult. And vertical up, down, incline and overhead is the most difficult welding process. However, if structure has to be maintained, when structure is fabricated, flat or horizontal welding is sufficient. But if it is maintained at the side, then sometimes all type of this welding will be skill on this type of welding will be required by the welders. Now this is also another 3 types of things in manual metal arc welding, that depending upon the machine's precisionness, that whether it will be transformer type, rectifier type or inverter type. I am telling you, nowadays inverter type machines are used mostly. Transformer type machine are not acceptable nowadays because it gives lot of cracks in the welding position. And electrode is another thing. Now let us not go into the details of mechanism, that electricity connection etc. of 3 types of welding machine. Nowadays only I think this only inverter type manual mechanical welding machine is available. Rectifier or transformer hardly available, and even if it is available, we should try to avoid that. Now I am not going into the details of mechanism all these 3 machines. This is the process. Just I am speaking. All of us we know that how this process are employed at the site. Now this is okay. Now here one thing all our fabrication engineers must understand: when we are using electrode, that how to identify the electrode which will be employed in manual metal arc welding at the site. Now as per AWS A5.1, the nomenclature will be there. For example, E6023 or 6013, something like that. What does it indicate? E indicates the electrode. First 2 digits indicate the minimum tensile strength in kilo KSI, that is PSI, that pound per square inch. Then it is converted to kilo SI. Means if it is 6012 is the grade of the electrode, 60 is the maximum tensile strength level. 60 into 6.9, almost 4.9 MPa will be the strength. That we need to understand. Whatever number are there, if we want to know the maximum tensile strength of that electrode material, that we have to multiply the first 2 digits with 6.9. KSI is converted to MPa by multiplication of 6.9, almost 7. Then third digit indicates the position. 1, 2, 3, 4. They are telling that 1 means this electrode can be applied in all position. 2 means it can be applied in flat and horizontal position. 3 only in flat position, and 4 is vertically down position, etc. So as I have told, there are a number of positions in manual metal arc welding. So normally 60, after that 1 written specified in the electrode, we should adopt that because 601 is applicable for all the positions. And then last digit will indicate the type of coating. Now what are the type of coating? You can see that they are telling that if the indication, as I have told, 6012, then 12 will indicate the flux of the electrode is high titanium sodium, and it can be applied with both AC and DC current. So that is the meaning of the number. So whenever we will select the electrode, then we have to be, first we have to know the strength of the parent material, then accordingly we have to select the number of the electrode. Normally for structural application 60 and 70, because when it is 70, then the tensile strength will be 7 into 7, around 490, more than 550, and if it is 60, then 6 into 7, so 420 is the MPa of the tensile strength. So if our parent material is 250 grade or 300 grade, we can get 60 number electrode. However, if the plate strength is more than 350, we have to go E70 category electrode. Then electrode, depending upon the flux, there are three type of electrodes. Fluxes are there: rutile type, basic type, and cellulosic type. The applications are there. Rutile is very common for general purposes. Everywhere it can be used. Basic electrodes, that the flux combination has been given here, that it will have calcium chloride and calcium and other alkaline carbonates as its flux, and it will be applicable only in overhead and vertical position. And cellulosic electrode is the most costlier. These are used in shipbuilding and pipeline, where that even not only crack, even hole is not permitted. So for precision welding, we have to adopt the cellulosic electrode, because in that case foolproof welding is possible. You know, shipbuilding and pipeline, they are subjected to water, so we cannot allow any porosity in the electrode. That's why cellulosic electrode will be applicable there. Then some parameters are there. Once electrode is selected, depending upon its diameter, how much current voltage will be set in the machine, that guidelines is given here. Then we are coming to MIG welding, that metal inert gas welding. Welding process utilizing a conjugate electrode and shielding gas. You know, during the welding, the steel will be melted and it will come into the contact of the moisture. Moisture is present in both air and water. So in rainy season, normally we avoid welding, because moisture, exactly in the moisture there are hydrogen and oxygen, both are there. If hydrogen and oxygen go into that melted steel, when the welding will be carried, then oxygen will form the slag, that is oxide, which will make the steel impure. That's why slags are removed during the welding. But another thing is hydrogen. Hydrogen will go into the liquid metal. Now in liquid condition, solubility of hydrogen is more, but once that liquid welding metal will be solidified, then solubility of hydrogen will be less and hydrogen will try to come out. But if solidification is very quick, then hydrogen will not be able to diffuse out. As a result, this will avoid these cases. MIG welding is adopted, where during the welding some shielding gas will be there, which will separate the weld fluid from the atmosphere. That shielding gases are normally carbon dioxide, helium, and argon. These are inert gases. These things will not allow that air to react with the weld fluid. So that's why MIG is adopted nowadays to make the welding without any defect. However, it will be costlier compared to the manual metal arc welding. Not only that, skill requirement of the welder is also more. This is the schematic diagram of the welding. Now I am not going into details, that its applicability is shown there. Now it is submerged arc welding. If the strength of the steel is more than 350 or 400, something like that, then submerged arc welding will be adopted in the workshop. Submerged arc welding is totally automated. It is automatic welding. It cannot be carried out at the site. It will be adopted in the workshop only. It is a costlier, however, very fast welding method. In this method, what will be that, again, consumable will be the same, similar to MIG, that is the wire electrode. Shielding will be provided the gas granule, consists of lime, silica, manganese, oxide, calcium, fluoride, etc. These things will, when will be melted, it will form the gas, will seal the weldment. Then flux act as the thermal insulator, which will not allow heat to come out. So welding will take some more time for cooling it. As a result, that it is one type of heat treatment will be taking place there. Maybe normalizing will take place there. As a result, grain refinement will take place, as well as that weld metal will be more ductile. It is automated process, high speed. However, it is very costlier. Then submerged arc welding, this is the advantage or description. I am not going into that. So this is the basic principle. Now another is flux core arc welding. As I have told, flux core arc welding nowadays very much adopted by the pre-engineer building companies in their workshop. It gives most defect-free welding. However, it is also very costlier and automatic method. Here the thing is, in MIG case, it was bare electrode was the electrode, but here some flux element like chloride, calcium oxide, etc., will be inserted into the that electrode. So by this way, welding volume will be more, as well as that flux will seal the welding pool. As a result, oxidation will be minimized or eliminated. So this is the flux core arc welding. Now inspection before welding and inspection during welding is given in our code IS 9595. It is the only available biggest course in welding, though America and European, there are a number of codes are there depending upon the application and situation of the welding where it is taking place. But in Indian condition, we have only the one code IS 19595, which is prescribing what precaution we should take before welding and during welding what should we check. Welding is such a process that before welding some preparation is required, during welding some precaution is required, and after welding also some care has to be taken to eliminate the defects. And another is after welding, what are the inspection will be there, that is given in IS 822. So we are having two codes exactly. One is 9595, another is 822, where it is described after welding what are the things have to be checked and its procedure given in details there. Now defects in welding. What are the defects in welding? Crack, misalignment, distortion, porosity, discontinuity, reinforcement, underfill. Let us see one by one. Spatter, incomplete penetration, arc stride, slag intrusion, incomplete fusion, and lamellar tearing. Let me describe one by one. These are the, that's why I have told that welding is critical compared to bolting, because number of defects are there and we have to take care all the defects. Now this is simply figure you can see and you can understand what I am telling about the misalignment. Exactly after during welding it will be straight, but after welding when weld pool will be shrink, that it will be distorted and misalignment will take place. So exactly that's why it is suggested at one go full welding should not be there. We should give some time to make the weld pool cool, and during cooling some bend will be there. Then we have to apply welding from opposite side so that this bending will be again balanced. Otherwise what we have to do, after one run of welding we have to make the material straight before the second run of welding. When again it will be straight, again the second run of welding will be carried out. So this is the wrong alignment or misalignment. Now another is distortion. Simply you can check that during welding, after welding, before welding you will not be finding anything. Like after welding, when the shrinkage will take place or when the weldment will be cool, this type of defect will be created. So that's why this welding should be done inside the workshop in controlled environment. If we go to the site, it will create problem. Now another is crack. Crack is the most dangerous thing in the welding. As I have told, there are normally three types of crack. One is hydrogen induced crack, another is solidification crack, and another is your lamellar tearing. Now one by one, hydrogen induced crack, as I have told, that during welding hydrogen will be trapped inside, and after the when the weld pool will try to be cooled down or cool down, that hydrogen will tend to come out. But if it is not possible to diffuse it out, then it will remain trapped inside the weld pool, and sometimes it will make the crack. And solidification crack also similar thing. If some foreign materials are there similar to oxide during the welding, then during solidification stage, that impure material will not chemically combine with the parent steel. As a result, that due to difference in that coefficient of thermal expansion during solidification, that both whirlpool and the foreign particle will not contract in the similar manner. As a result, some crack will be formed. So that is called solidification crack. And lamellar tearing, I'll describe a little bit after that. Now, this is very easy to try to understand convexity and concavity. Both are exactly. Convexity will not create any problem after welding, but it is the wastage of the welding. That's why it is considered a defect. And concavity is the exactly it will make the welding weaker. So we cannot allow convexity. Somehow we can accept, but some wastage will be there. But concavity totally it should be rejected straight away. Then reinforcement, when plates are joined in butt welding will be there in both the side, top and bottom, excess welding will be there. That is called reinforcement. And just opposite to it, if that reinforcement is not there, welding is less, it will create another things, underfill or incomplete joint penetration. So both are exactly defect. So reinforcement we can accept after grinding the excess welding, but underfill or incomplete joint penetration we cannot accept. Then undercut and overlap. You can see from the left hand side figure, undercut means during welding heat generation was so much that it has exactly eaten away its parent material itself. So as a result, after welding, parent metal has become weaker. And overlap is another thing where weld pool will be flowed, will overflow over the welding position, but it will not stick to the parent material. So undercut and overlap both are defect. Then incomplete fusion, you can see during fillet welding, exactly inside there are some gap or void is there. It is not welded. That is called incomplete fusion. It may happen in butt welding as well as that in at the fillet welding. Now spatter, you can see very easily. You can see flat spatter, arc strike, and lack of fusion. Both you can see. So I need not describe. It is clearly visible in the picture. Porosity also you can see that some holes have been formed inside the welding. Then lamellar tearing. Lamellar tearing, let me describe a little bit. It is exactly not the defect of welding. Rather, it is defect of parent material itself. When parent material was rolled in the steel plant, due to some reasons, some crack has taken place during the rolling. However, it was not detected that time. But after welding, when that it will shrink or it will pull down, some pulling force will be created. As a result, that crack will be widened. So that is called lamellar tearing. Though it is the defect of rolling, it is only viewed during the welding. That's why this type of defect is clubbed with the welding defect. Now hydrogen induced crack already I have told in details. So to avoid it, simply we have to select that that low hydrogen electrode. You know, in SMAW, whatever the electrodes are there, and another terminology you might have heard, that low hydrogen electrode. So low hydrogen electrode is it will be comparatively costlier, but it will not give hydrogen to go into the weld pool. So sometimes, especially in when the moisture will be humid, then that low hydrogen electrode will be adopted for the welding. Now after welding, as we know the defects, now we should go for the testing, that whether welding is perfect or not. First is visual test. In visual test, we can find out that following: misalignment, distortion, convexity, concavity, scatter, spatter, reinforcement, underfill, overlap, undercut, and porosity. Almost 90% of the defects can be seen with our open eye. So in visual test, if any of the things is viewed, so our welding should be rejected. However, all these defects may not create much problem during the service life of the structure if we allow. But when quality is the concern, we should not allow. Then we are coming test of welding. First is destructive test, another is non-destructive test. So obviously, non-destructive test I will be just describing after some time. Destructive tests include tensile test, bend test, hardness test, impact test, load test, and nick test. These tests are being carried out just to know whether welding steel, that welded portion is stronger than parent material or weaker than parent material. In the matter of principle, welding has to be stronger than parent material. Otherwise, there are some possibility that steel may fail because structure is designed considering the strength of the parent material, main steel plate, etc. So welding has to be stronger than that so that the structure should not fail at the welded portion. And to know that these destructive tests are there, tensile test will give us the elongation, that yield strength, and maximum tensile strength. And bend test is also three types: root bend test, face bend test, and your side bend test. Three type of bend tests are there. Then hardness test is there. If the welded portion is having more than 400 Vickers hardness number, then there must be some crack. Welding will be perfect if that Vickers hardness number is less than 350. That's why hardness test we should carry out. Then impact test, we must know that in the 2060 there is impact strength is given, which is related to the temperature. So in welded portion, again we have to test it that it is really absorbing more than 27 joules or not, whatever prescribed in 2062. Then load test is another test that sometimes we put the load on welded position. Normally it is being carried out in the prototype, not actually welded member to be fitted in the structure. So before welding, before actual structural fabrication, some specimen is welded and subjected to load strain to check that whether welded position will be able to take the load or not. The nick brake test, it is one also brake test. Easily we can do with the help of hammer, so that in hammer at least it will not fail. Now we have shown you some picture to understand these things. Tensile test, we know that we have to pull the welded position from two sides in universal testing machine. We can find out the elongation, minimum yield strength, and the maximum tensile strength of the welded portion. Now this is the face bend test and root bend test. You can see depending upon the direction of the bending, we are having two types of bend test. One is face, another is root. I should not describe it in detail as it is clearly clear in the picture. IS 1599 is the code, related cost. Another is guided bend test. This is also test that welded portion should be kept on this ram, and after that plunger will be pushed hydraulically, it will bend. So if the plate thickness is more, really we have to use this guided bend test. Otherwise, really manually we cannot bend the test portion as I have shown in this picture. So guided bend test is the mechanical, and we push the plunger with the help of some hydraulic machines. Then free bend test, yeah, this is one type of test is there. This by this way you can check both root bend test and face bend test. Then file test is one thing is there that to find out the hardness. They are telling that to know whether hardness is less than 350 HBN or not. Very simple, you take the mechanical file, and file should be. Now should I start, sir? Hello?
Yes, sir, you can
Continue,
start.
sir.
Yeah. Now to test the hardness, exactly welded portion, we cannot take always welded sample to the hardness testing machine. So simple manual method is there, file test. In file test, what we do, that we take the mechanical file, and after that on welded portion we just carry on filing, and after that if the hardness, if the welding portion is harder than 350 Vickers number, in that case it will crack. Otherwise it will be simple filed. So this is the simple test. Otherwise, if the specimen is very small, then we can take it to the hardness testing machine. Now Grinnell test and Rockwell test and Vickers hardness test are there. Normally we refer our all the testing in terms of Vickers hardness number. So it indicates what is the number and what is the other. Now the impact test, as I have told, that is Charpy V-notch test, popularly known. IS 1499 is the related post in which that notch test is carried out. Some notch will be created in the welded portion, and after that heavy load will be impinged on it. If it cracks, certainly it will crack. Then we will measure that how much energy has been there or has been put to destroy the piece. It has to be minimum 27 joule minimum. If it cracks, if it breaks below 27 joule, then the welding is not acceptable. This is the schematic figure. We know all of us that how the impact test is carried out. The nick brick test, simply on welding, make a just slot, and after that you hammer it on the top. So this is the test of exactly side bend test. So in case the welding is very good and ductile one, then it will not break. And if it is not non-ductile in nature, it will break here. Then we are coming to non-destructive test. Exactly in practice purpose, first we will carry out non-destructive test, then we will carry out destructive test. But somehow in my presentation, I have described that first. Anyway, the sequence will be reversed. So in non-destructive test, what we will do to find out the crack mainly, that there should not be any crack. So for determination of crack, we are having two manual things. One is liquid penetrant test, light dye penetrant test, another is magnetic particle test. And another three type of tests are there: ultrasonic test, radiographic test, FD current test. Now in dye penetrant test, IS 3658 is the relevant code. Kindly go into the details. What we will do, exactly on the welding surface, we will first make it clean. And after that, we will put some liquid to clean it. Now after that, we will give one penetrant. Then again we will clean the surface, and after that one developer paint is there, we will put it. In case of crack is there, you can see that color will come out. So we will be able to detect that the surface is having crack or not. So this is called dye penetrant test. Means we are giving two types of dye. First one dye to which is having less that viscosity, it will go inside the crack. And after that, one developer will be imposed there, developer will be there. It will extract the color, so that color will be visible. So this is dye penetrant test. Another is magnetic particle test. IS 3703 is the related code. So for details, kindly go into that. Simple principle is that on the welding portion, you put a electrode magnet and some magnetic grit particle, iron particle. So if some crack is there, then this type of some line will be created, because two poles will be there, and magnetic iron particle will be accumulated on the crack. And if there is no crack, then it will not be able to disturb the distribution of the grit. As a result, it will be at random. But if crack is there, two poles will be created, all grit will be accumulated there. So magnetic particle test is also very low cost. But only limitation of these two things, the dye penetrant test and magnetic particle test, is that it can detect only surface crack, not inside crack. Now, if it is inside crack, then we have to go for that ultrasonic test. IS 3664 is the relevant code. The methodology has been given here. You can see left hand side that one inside crack is there. So in ultrasonic machine, the probe will be placed there, and ultrasound will be there. And we know ultrasound is deflected where the surface, density of the medium will be changed. So if crack is there inside, then from the crack, ultrasound will be reflected back. So by that way, in our screen, we can see at what depth or at what location crack is there. So if crack is there, we have to reject the welding. Now exactly this ultrasonic test is so carried out in angular way as well as the under of water. All are there. So in the code, this 3664, it is given how to carry out the ultrasonic test within water also. Now radiographic testing is required where that water, gas, etc. will go through the conduit. Means when pipeline will be welded, then only radiographic testing will be carried out, because we cannot allow any hole or crack inside it. Exactly, in structure, we can allow some hole. If the crack is not very big, we can accept it. But when gas or some liquid oil or water will be flowing inside the pipeline, then really we cannot allow any hole. And to find out the solidity of that welding, we have to put the X-ray. 2595 is the relevant code, and that is the basic principle. You see one tubular surface which has been welded. Now X-ray is given on the top, and X-ray plate is film is the bottom, and in the film, similar to as our body is also X-rayed for our bone condition, this is the same condition. If any crack is there, that will be reflected in the film. Then national standards, these are the codes and standards related to your welding, which we should refer on case-to-case basis. And some international standard also I have mentioned here. Then inspection of fabrication. Now when fabrication is being carried out, in the morning also you have asked question, and a number of times you will be asked that exactly during fabrication what should we inspect, what should we not inspect. Normally fabrication is inspected based on the experience, but I am telling you IS 7215 is there to give you the fabrication of steel structure inspection, and during welding and bolting what should be the tolerances level we should accept. That guideline is giving. So IS 7215 is the relevant code that which will be useful for fabrication. Now, sir, another two subjects is there, corrosion and fire. Should I continue? Hello?
Yes, sir.
Sir, exactly fabrication, though
Pardon
time
me,
is exactly we are having, I am having two small presentation on corrosion protection and fire protection. Should I continue?
Okay, sir.
Okay. Now,
You wish to continue, sir?
yeah, I'm continuing. I think it will take another 5 to 10 minutes only.
Okay, sir.
Okay.
Okay, sir. Okay, sir.
Exactly as I have told you, sir, fabrication engineering is not taught in any of the class, and that fabrication is relates to many disciplines. Now I was talking so far about the mechanical engineering and civil engineering. Now corrosion is the part of the chemical engineering or metallurgical engineering. Corrosion is a very natural phenomena. Natural phenomena, exactly when steel is produced, that steel iron ore is there. Iron ore is there. That is the magnetite and hematite. Magnetite and hematite is nothing but the carbonate form of the element, that is the ferrous. And we know that none of the element are stable except inert element. None of the element is stable in the earth. All the elements form the carbonate or oxide or nitride to be stable in the earth. So when we take the iron ore, that is basically FeCO3 or Fe2CO3 or Fe3CO4, that is hematite and magnetite. These are put in the blast furnace. Here we take out the Fe separatively, and as I have told yesterday, in the form of deoxidation, we make the iron and carbon out of it. Now, when we are in that case, we are making the ferrous element is unstable in the nature. Now, when we make the steel is a compound. It is chemically bonded material, where ferrous is the alloy of carbon, manganese, sulfur, phosphorus, as well as silicon. So, number of elements are in chemical combination that gives us the steel. So, but it is the unstable form of the material. So, when structure will be in the open position, so it will come in the contact of oxygen of the air and moisture. So as a result, it is the natural phenomena that again ferrous will make the chemical reaction with the oxygen. As a result, ferrous oxide FeO will be formed, and that phenomena is called the corrosion. And by this way, that ferrous will be eliminated from the steel. So it will make the steel of poor quality. So as long as the structure is in service, our philosophy of the corrosion protection will be how to remove air and water from the surface of the steel. Means we have to prevent their contact so that no chemical reaction take place. Otherwise, corrosion is the very natural process. During extraction of the steel, we have put the energy to extract it. But when that ferrous will go to its oxide form, it will not require any energy, and natural atmosphere it designers have some role to play, designing and detailing to minimize the corrosion, so that detailing of the structural element in such a will be that there will be the least possibility of accumulation of moisture or dirt or something, so that surface will be clean. Then another is galvanizing, painting, thermal spraying, and cathodic protection. Let me briefly one by one. In the morning, Mr. Basu told about the painting. However, for corrosion protection, some other methodologies are also there. Galvanizing is the coating of zinc. Zinc is the best method of giving the protection. We know that in galvanizing, normally steel sheet or any other section that is put in the zinc bath, and when it is taken out and dried, zinc is exactly come into the contact of the steel. It gives the best protection to the corrosion. That's why our all water line or even that electrical transmission tower or that railways, electrification tower, that tower or pole, those things are subjected to galvanization. If properly galvanized, then the corrosion will be resisted for at least 25 to 30 years. In the morning, you are asking the question that in the toilet or bathroom, how the steel section are getting that protection from the corrosion. I am suggesting not only painting, though painting is the best method because it gives attract viewer, but before painting, if galvanizing is carried out, that will give the best protection. However, if the steel section is galvanized, it will be difficult to weld. That's why that another process has come up now, that is called thermal spraying. I will discuss after little after a few slides. So galvanizing is normally carried out with the in the plant, in industry. If required, any section can be galvanized. That is the best method of the protection from the corrosion. Now I am coming to painting. Painting is involving three processes. First, I have to carry out the surface preparation. Then paint we have to apply, and then paint blend, that is the quality of paint itself, and then paint manufacturer. Now, first thing you see, this is the contributing factor. If painting has to sustain for more duration of time, then surface preparation is most critical. During painting, what happens? That surface are normally not clean, because painting that in our Indian culture, that cost of painting is calculated based on the area, that is square meter, how much I have painted. So once it is painted, then our bill is passed, we get the money for that painting. So in that case where there is no clause of surface cleaning, so surface cleaning is the neglected thing. But if surface is not cleaned properly, the paint is a chemical, it will not adhere to the substrate surface, that is the surface. So that's why they are telling that success of painting is mostly by the about 60% contributed by the surface preparation. And after that, how we are applying the paint, we have to know that immediately after surface preparation, at least primer we have to apply, because if after preparation of the surface, if we don't apply the primer, again moisture will be ingressed on the surface. So normally in our culture, suppose a structure is at the open side, some labor is cleaning the surface today and primer will be applied tomorrow. Exactly, the purpose has failed already, because during the night time, that some moisture has already again immersed, or it has gone to the contact of the steel. That's why it is advisory that within 1 hour of the cleaning, in dry condition, not in moisture condition or in rainy season, primer has to be applied. That is the guideline. Now, and surface cleaning, there are some standard. IS 9954 is giving us the standard. From there, number of standards are there that how surface will be cleaned. I am telling you that surface of the steel can be cleaned by brush itself, by grinding, by chemical cleaning, by your grit blasting, by sand blasting. Sand blasting is mostly used at the site, but as sand powder creates the pollution, not only that hazardous to the health, nowadays it is advisory there that sand blasting will not be accepted. So grit blasting will be accepted. Grit means it is iron grit only, that will be impinged on the steel surface with high velocity of your air. That is the pneumatically it is impinged, and steel surface will be very clean. And I am telling you, as SA 1.5, this is the standard, or SA 2 is the standard as per IS 9954. Exactly, the steel surface can be seen like a mirror. Our face we can see, but we know that this type of cleaning is not taking place in structural application. Anyway, that is the guideline that IS 9954 should be adopted for the cleaning purpose. Then what are the paints we applied? Mr. Basu in the morning already he has told you that red oxide, your primer has to be applied first, 1 coat or 2 coat. Then 2 type of painting is there. Sorry, another type of also red oxide is now very poisonous. So now zinc chromate priming is actually replacing the red oxide. Though both the things are going on, but zinc chromate will be little costlier, but that is more environment friendly. And followed by the ready mix paint of one your painting, that red oxide painting, or another is aluminium painting. 2 types of things is there. Okay, red oxide painting is there, 123 IS 123 is the code, and aluminium coating, I think another code is there, IS 2339. So if the area we are where we are painting, if our expectation is less light, for suppose 3 to 5 years, then we can go for the priming and followed by the red oxide painting. But if where corrosion is not a very severe problem, but we are expecting a painting life of around 10 years or 12 years, then our primer should be the zinc chromate primer followed by the aluminium painting IS 2339. Nowadays, in most of the cases, our structure are painted with aluminium painting. Then another railway provisions are there. Nowadays, it is coming into our IS 8669 also, that if we expect more life, around 20 years of painting life in the structure, then what should be our that painting procedure? So first thing is that surface preparation has to be cleaned with the up to the grade of SA 2.5 as per IS 9950. Then we have to give the primer coat. Primer coat has to be that not red oxide primer, rather it will be epoxy zinc phosphate primer. Phosphate primer it has to be. So primer quality has changed. It is epoxy zinc phosphate primer. Epoxy is the compound which acts as the adhesive. So that's why epoxy and steel, the adhesiveness is very good. That's why epoxy zinc phosphate primer is applied if our expectation of life is more. Then we have to give some intermediate coat. In intermediate coat, we give that epoxy micaceous iron oxide. We have to give 1 coat, and finishing coat has to be that. Finishing coat has to be your finishing coat has to be the RDSO specification postal polyurethane red oxide. Again, it is your that same epoxy based polyurethane red oxide painting has to be there. If it is adopted like that, then our painting life will be more than 20 years. Even in seashore, we can expect that of life where the corrosion is the most problem. And for your guidelines, that around by 1 coat, I mean that it is 40 micron approximately. By 1 coat, when it is manually painted, 1 coat means 40 micron. Now thermal spray. As I have told, galvanizing is possible in the industry only. Thermal spray is the substitute. In thermal spray, again, aluminium or zinc will be sprayed on the surface. Aluminium or zinc will be sprayed on the surface. So there is some thermal spraying. Your schematic diagram is there. One nozzle will be there. There are some your metallization is a process of thermal spraying, means it will be heated and electrified aluminium, zinc or zinc aluminium alloy. It will be plasma like things and it will spread on the steel surface and it will stick to the steel surface. So here the application it is finding in many railway bridge application. We can apply it in many other places. As you have told, in the toilet it will be good application, that as the steel has been welded at the side, if corrosion is more problematic, then first we have to apply the thermal spray with thermal spraying gun, and after that we should go for the painting. That it will be that what will happen once paint is being removed, steel is not corroded because another layer of thermal spraying is there. So when painting is getting removed, this is giving the indication that I should repaint the structure again. So during fabrication, if the portion of the steel is subjected to that type of severe corrosion, then we have, before painting, we should apply the thermal spraying. And the related code is there. Already I have told IS 5905 codes are there. Exactly in India, we have all the codes, but very less we refer because of that single reason that fabrication engineering is not properly in our colleges, and it is a multidisciplinary activity. Then these are the standard we can refer to for different purposes. Now fire prevention. When steel building nowadays is very common, and when steel building is getting fabricated, fire protection is the another criteria we have to select for proper fire prevention. Now, what is fire resistance? Fire resistance is the duration of the time up to which an element of building structure is able to fulfill the required stability, fire integrity, or other expected duty in a standard fire resistant state. IS 3809, it is there. It is expressed at half hour, 1 hour, 2 hours, and likewise. Exactly in India, anyway, steel building are very less, but we know the failure of the World Trade Center of New York. World Trade Center was a composite building where number of steel sections were there, and we should know that after explosion, this building for total collapse, it takes more than 2 hours time, and during this 2 hours time, thousands of people could go out of that structure. That's why calamity was less. Exactly during that office hour, as I have heard, that more than 5,000 people were there, but due to the fire resistance of the structure, more than 2,000 people could have been evacuated. So in fire resistance is the terminology where the structure before collapse, it will take half an hour, 1 hour, or 2 hours. In Indian condition, multi-story steel building has not come up in that way, but maybe after few years, it will be the consideration. Up to 1 or 2 or 3 years, 3-story steel building, normally half an hour fire resistance is sufficient, and our normal steel is having that type of strength. As a result, we don't consider fire preventive measure as the additional, as it is additional cost, we normally don't require. But if our steel building is more than 5-story building, then we have to take fire resistance seriously. Now there are some active fire protection method: automatic sprinkler system, smoke and fire detector, alarm system, water supply system, hose cabinet, fire extinguisher system, and personnel involved in the fire department response. These are normally active fire protection system nowadays installed in any office building and big residential buildings. So this is active fire. Now what is the passive fire protection? Passive fire protection means first step is we have to select the fire resistant steel. As I have told you already yesterday, 15103 is the steel by which fire resistant steel will be there, where that steel will be more fire resilient. As steel will lose its strength after 500 degrees centigrade, it will take more time to reach that stage. So the steel rise in temperature will take more time. So first process is select fire resistant steel, but that fire resistant steel will be costlier. So many clients will prefer that instead of going for fire resistant steel, we can go another way of fire resistance. Another, what it may be, filling the core of the hollow section. So if we use the hollow section in our steel beam and column, then we can put the core full of water. However, this concept is popular in European country, has not come so far in India. Using water filled construction. This is the same thing again. In the column, you can give the water. So water can be filled or water can be passed through continuously. Another is composite construction. Composite construction means we are using concrete as well as steel almost equal way. So in that case, concrete will take lot of time. Actually, concrete absorb a lot of heat, so steel will be exposed to less heat. Not only that, another thing, when these are in combination, their temperature rise also will be in the same manner. So as a result, that concrete will deaccelerate the rising of the temperature of the steel. Then box type cladding, that you just encase the steel column and beam with some your gypsum board, etc., so that the heat will not go into the steel column. And other important methods are also there. Now this is some other method: concrete encasement, spray protection, board and casing system, and intubation coating nowadays coming. So as the steel structure is painted to prevent from the corrosion, so intubation coating has come up in the market. It is not only giving the beauty of the steel structure, but also it is giving the fire protection. The feature or the properties of the intubation coating is that once this coating is subjected to fire, there some your bubbles like balloon will be formed. As a result, that will not allow heat into go into the inside of the steel. By that way, intubation coating will make the steel member safe. So now, after all these things, as I have discussed in the very briefly, so in the conclusion that as lack of concerns or lack of quality concerns, some defects in the structure. Now, after the structure has been built with so many processes, whether that is acceptable or not acceptable, only one code is available in international market, that is BS 7910-1993, guide on the method of assessing the acceptability of flaws in the metallic structure. Means it is steel structure. So in steel structure, after fabrication, if some flaw is detected, really we cannot reject the whole structure because it is very costly asset for any country. So based on that flaw detected in the structure, whether that structure is acceptable or not, for that guidelines is given this British standard 7910. With this, I am concluding my presentation, and the session is open for your discussion.
So thank you, sir. We have few questions to ask. Shall I begin, sir?
Yeah. Now,
so the first.
1 minute, just let me stop the presentation. Yeah.
Okay.
Okay. Yeah. Now you can ask me.
So, in spite of its advantages, why cold cutting is not preferred by fabricators?
Pardon, sir. Once again, madam.
In spite of its advantages,
yeah,
why cold cutting is not preferred by fabricators? Why water cutting is not preferred by fabricators?
No, I am unable to follow you because
Sir,
you are talking about the bolting.
She says cutting. Why cold cutting is not followed?
Why water cutting is not preferred by fabricators?
What is that? Water fitting?
Water cutting.
Oh, water jet cutting. Okay,
yes.
Water jet cutting is having some limitation, though it is CNC operated. First and foremost thing, it is very costly. So that's why plasma cutting is adopted. Plasma cutting is adopted comparatively because of the precision as well as the cost effectiveness. Okay, water jet cutting and the your lesser cutting, both are technically feasible but may not be sustainable on economic point. That is the thing. So that's why for bolt holing or any type of cutting, nowadays all advanced workshop is having that your plasma cutting. Both plasma cutting, water jet cutting, and laser cutting are technically feasible. So only criteria is the cost. So plasma cutting is most acceptable, and not only that, plasma cutting machines are available in portable manner also. It is not necessary only in workshop it will be installed. As I have shown you one portable machine that can be taken to site or any places. Normally water jet cutting or laser cutting, these machines are installed and CNC operated and particular one place. But plasma cutting machine are portable transport. You can take it to any places. Okay, that is the advantage of that plasma cutting compared to water jet cutting.
Okay, sir. Sir, in slide number 9, both the standards you have mentioned deal with cutting related tolerances.
Okay.
What is the difference between the two?
8 minutes, just cutting related tolerances. 8 minutes, let me see. In which slide you are talking
slide
about?
Number 9, sir.
8 minutes, let me check. Slide number. No, slide number 9, it is the tolerances 1852. That is the tolerances of your steel section when it is purchased from the market. Okay. And next slide, it is showing that once it is purchased, then what should be the dimension of that plate? Because you know that dimension will be varied. It cannot be, steel is a rolling methodology such that normally some deviation in the dimension it is there. So that's why whether steel is acceptable or not acceptable, because their dimension are given in the related code. Whether it is plate, if it is plate, then 1730. If it is beam angle channel, that is IS 808. But they are having the number of deviation in the dimension. So to check the dimension, for example, I have given, for example, if it is one plate of 2 meter by 2 meter, you will be finding, because it is roll section, so instead of 2 meter wide, in between some along the length, you will be finding 1.9 meter is the wide. So why should I accept? Because in that case, the plate we cannot use properly. So that's why it is always preferred the dimension should be within the range. That's why IS 1852 giving the tolerance level on different measurement or parameters.
So that's all from my side.
Sir, I have few questions.
Yeah.
Yeah, sir, in the field scenario,
Yeah.
whenever they go for fabrication, I have seen the fabricators cutting for making the bolts, the
Yeah.
whole bolt holes.
Yeah.
They use this gas cutting and they
No, not
make this
acceptable
holes.
at all. Not
Yes, sir.
acceptable. That is the, because they are having the readily available Oxy Acetyl gas. It is
Yes,
not
sir.
at all acceptable. That I have told that IS 800, because you are designing the structure as per IS 800, and IS 800 already recommended how much the tolerances will be there in the bolt hole. So if you go for the gas cutting, you will not be able to maintain the tolerance. As a result, after some time, bolt will be loosened, or the plate will be, or the joint itself will be the weaker. So it is not acceptable. If quality we have to maintain. As I have told yesterday also, quality concerns is the main problem in India. Somehow,
Sir,
you want to carry on the job. Yeah, tell me.
another question, sir. Sir, we have this NDT test and we have the destructive test. Both are there.
Yeah.
Which one is actually preferable?
No, if it is welding, you see two things. Welding is taking place at two things. One is pipeline carrying gas or water or oil or something like that, some liquid or gaseous things. In that case, we have to go for the radiographic testing, because even we cannot allow the hole. It has to be hole proof. But in case of structure, we can allow that hole, as well as to some extent some crack also we allow. That's why ultrasonic test is comparatively cheaper. So we employ it ultrasonical test. We can test it anywhere, and so that we can see the how much is the crack, and then if it is acceptable, then we accept the structure. So in normally structural application, you will be finding ultrasonic testing. But if in case of it is pipeline carrying some liquid or fluid, it has to be your this radiographic testing. That is X-ray.
Okay. Sir, in such cases, if there is any leakage, is
Yeah.
there is that we have to weld again, or we should have to use any adhesives like that?
No adhesive will work, because already chemical is going into that. So no adhesive. Simply we have to melt the welded portion. Again, we have to weld. So pipe welding is the very difficult weld. That's why most of the time, unless it is at the site, you will be seeing that plastic pipe welding is there at your that under your that submerged arc welding, and where pipe is rotating and submerged arc welding, the torch is there on the top. Because if torch in some angle, then proper deposit will not be there. That's why pipe you will be finding it is rotating. But in the site, it is very difficult. We have to dig out that whole portion. We have to make the site dry, and after that, we have to check the welder skill, whether he is able to do the vertical welding and overhead welding or not. So all welder cannot do that type of welding, because pipe you cannot rotate there.
Correct, sir.
So that is the difficulty. That's why normally pipe welding is done at the workshop. But sometimes during maintenance, what you will do? The pipe has gone taking the water, gas. Nowadays in our city life, it is normal. Somehow water leakage has started. What to do? We have to do it in the site only. We cannot do anything. So then welder skill is the main thing.
Yes,
He should be able to do overhead welding. That is the most skillful job.
yes, sir. Sir, I think thank you for your wonderful information, which you have given. Many times, what we do, we develop the fabrication. We do not develop the fabrication drawings. We give normal drawings, and we not go for the fabrication, because
for that, okay, we have given the material. It will college curriculum. Nowhere it is there that called fabrication engineering. And fabrication is such a thing, multidisciplinary. Steel is produced by metallurgists. designed by civil engineer and being erected by the mechanical engineer. Corrosion
Yes, sir, yes,
protection and metallization, these are all chemical engineers' job.
Yes, sir.
So,
Yes, sir.
so many multidisciplinary subjects are involved. So only we developed it based on our experience only.
Correct, sir. Because normally we do not give good fabrication drawing at all. We think that the fabricator is going to do everything.
Yeah.
But if we do not know these problems, if we do not check, for example, weld, as you said, if we do not use it, know at least NDT tests are there to check whether
Yeah.
whether the weld has been done properly or not.
Yes.
Then we will not be doing justice to our structures.
Yes,
At least, yes, sir. So I think you have enlightened us with that. And what are the things, though being civil engineers, we must also know what is exactly the fabricator is going to do and how he has, what is that we have to check in the
Yeah.
whatever the activities he does.
And not only
I,
that, a number of standards are involved.
yes, sir. Yes, sir.
So
Yes, sir.
who has time to read, read all these standards and to understand?
Correct, sir. Exactly, sir. Exactly,
Yeah.
sir. So you have given us all the standards and what are the things to be done in one single lecture. I think we are very thankful to you, sir. Thankful for
Okay.
we are very thank you for presenting such a wonderful
Again, sir, my request
presentation.
is take the
Yes, sir.
feedback and any question. Our institute is there. Just you send the question even after this course by email to
Yes, sir.
me. We'll reply
Yeah,
it. That is our job.
definitely, sir. Definitely, sir.
Okay.
Definitely, sir.
Okay, sir.
Thank you so much, sir.
Thank you.
I thank all the participants for being part of this presentation. Thank you so much.
Thank you.
So thank you, sir. We'll again meet tomorrow at 11 o'clock. Thank you, everyone. Thank you.